All right, welcome to a brand new module, and in this module we'll be focusing on working with text data in Pandas. So many times when we receive a data set, even if we're working with something like strings, the data may not be in an ideal shape for us to perform our proper data analysis. We may have things like capitalization problems. We may have situations where we have more than one thing represented within a cell and we need to split it up. We may have rendering issues, as we'll see in just a second, with things like currencies, many other different problems. And in order to solve those problems, Pandas includes many different string methods that we can call on a data frame or the series within a data frame to help us fix those problems. So let's begin by creating a new Jupyter Notebook. I'm going to click New here and select my Conda root environment. Let's give our Jupyter Notebook a name. I'm going to call it Working with Text Data. And of course, we have to import our Pandas library as PD. I'm also going to press the Escape key to go into command mode, and now I'm holding my B button to select or create rather some cells below for us to work with. And let's call our familiar read CSV method because our data set is once again stored in a CSV file, and it is called chicago.csv. So let's take a look. This is a pretty extensive data set. If I scroll down all the way to the bottom, you'll see that we're going into something like 32,000 rows. We once again have a familiar problem, which is at the very end we have a row full of null values. So we'll talk about how we can deal with that in the future. But we can see it's a pretty large data set, 32,063 rows by 4 columns. And what this represents is publicly available data of every employee who is employed by the city of Chicago. So we have the person's name, we have their title, we have their department, and their annual salary. And as we can see here that there are some issues here if we want to, let's say, perform some data analysis. For example, our titles here and our departments are in all capital letters. That's kind of a little bit weird. We see here that our names, our last names, and our first names are stored within a single column. So if I want to do something like separate them, like find the last name and the first name of each person in order to split it into 2 separate columns, we're going to have to find some unique string method to work with here. That's the kind of stuff that we'll explore here. In addition, I'm going to just begin here by storing this in a variable. I'll call it Chicago, and I'm going to preview the first 3 rows with head. I'm going to call our familiar info method on the data frame, which, as you may recall, will give us a summary of the data frame, including things like the memory usage as well as the data type that is being stored within each column. And we can see here that the last column on the right there, the employee annual salary, the values there are being stored as strings, as objects. And you can see here the reason that Pandas is interpreting this as a string instead of as a float is because of this dollar sign. Pandas doesn't have a concept of currency, so it's looking at that, it's seeing a dollar sign, it doesn't know how to read it as a number, and it's rendering it as a string. And of course, the disadvantage of a string is that we can't do numerical operations. So if we wanted to do something like find the average of the employee salaries in Chicago, we can't do that until we convert these values to floats. But we can't do that. We can't do an as type operation, for example, until we get rid of that leading dollar sign. So that's an example of the kind of formatting issues that you may run into in regular data. And in this module, we'll focus on all of the solutions that we can do to fix those kinds of problems. So to conclude, I just want to do one final thing. I want to see if we can optimize this memory usage a bit. There's really not much we can do in the name column. Those are all going to be unique. And as I mentioned, I can't convert this string to floating points yet because we haven't explored the string methods to convert the dollar signs, or rather remove them. The only real place I see where we can optimize a little bit is this department column. So let's take a look at the number of unique departments within this list. So as we know here, we have about 32,000 rows. But if I extract my department column and I call our familiar nUnique method, that's going to tell us the number of unique values in that column. We have 35 unique departments listed. And of course, I can also take that exact same series or column and call the count method on it to get the count of the total number of values in there. So as you can see here, we have 35 unique values among 32,000 total values. So it's a pretty staggering ratio. This is really a staggeringly small ratio, to clarify. And because it's so small, this is the absolute ideal kind of column to convert to a category, because there's no reason to store 32,000 string objects when we can just store 35 different category objects and just link every duplicate value to one of those 35 objects. So what I'm going to do here is extract my department column again. I'm going to call my asType method, and I'm going to give it an argument of category. We have to remember to actually reassign it back to the department variable, or the department series rather. That's going to overwrite the values with categories. And I'm going to actually copy this code and bring it up to here, since this will serve as our execution code at the start of each lesson. I'm going to execute this again. It's not going to look any different, but now if I call the info method, keep in mind our current memory usage on my end is about 1,000 kilobytes, but now that I've converted it from a string to a category, we are down to 783. So once again, I've reduced the memory usage here by 20 to 25%, which is pretty significant considering it's 33,000 rows here. So this is the code that we're going to need to get started, and in the next lesson I will start taking you through some of the most common string methods that are available in Pandas.